Joanna Simpson here at Quant Minds International in London. Joining me now is Thomas Raffinot, Head of Quant Investment Signals at AXA Investment Management. Thank you very much for joining me today.
Thank you for the invitation.
And you're here at Quant Minds talking about the interpretable supervised portfolio. What makes this methodology so innovative?
As a matter of fact, the traditional approach for portfolio optimization may be quite frustrating for portfolio manager or economist because there is no direct link between your explanatory variables, your signals, your macroeconomic data, and the way you should allocate capital. So for former economists like myself or my boss, it was very frustrating because our value added is in how we can add signals to our portfolio management framework. So what we decide to do is to change this framework. So traditional approach is starting by first forecasting the expected returns and then putting everything into the an optimizer. So it's an optimization process. We transform it into a forecasting process where we start by creating the weights, the way we should allocate capital, and we forecast the weights with a machine learning algorithm. So the innovative way is that we have a direct link between the way we should allocate capital and our fixtures, and we are using machine learning algorithms.
And how do you balance the complexity of machine learning models with the need for interpretability?
Machine learning algorithms are often seen as a black box. For many people, they don't want to use it. As in my job, I advise portfolio manager. They have to understand why they should change their position and so on. And the fact is, people hate algorithms. There is something called algorithm aversion, where people forgive mistakes made by humans much more than those made by computers. It may explain why economists still have a job, by the way. In fact, there are two ways to create interpretability with machine learning algorithms. The first branch is what we call post-hoc, after the event. We create the model and then we try to understand what was driving the forecast. But it does not make the model really trustworthy. What really we wanted to we want to trust our model. So we decided to go to another road, which is models that are interpretable by nature, such as regression, decision tree. But we still wanted to have the efficiency of machine learning algorithms, because at the end of the day, we are judged on our performances, not our beautiful framework. So we discover a bunch of statistical methodology that is not well known, and I don't understand why, but that's a fact, which is called RuleFit, where you transform your machine learning algorithm into a linear regression. The trick here is it is a linear regression with clever interaction. It's a two-step process. You start by creating many trees with your machine learning algorithm, and each path through a tree can be transformed into a decision rule by combining the decision speed. So you get many decision rules, and you then create a sparse regression. At the end of the day, you have a regression, just a simple regression. So you can really explain why you advise portfolio manager to change their framework.
And how can financial institutions integrate these approaches into their existing portfolio management frameworks?
The main difficulty won't be research. Research is difficult for sure, but everything is explained in the papers. Supervised portfolios, the code is open source, so it won't be the main difficulty. The main difficulty will be going from research to production. In fact, there is a step that is often overlooked in not in academic, because academic world do not care about production, but in companies, in asset management companies. In fact, you need to have a framework that is quite robust to be able to train your model, monitor them, be sure that your data are ingest quite on a daily basis without any issues. So it is called MLOps in the software engineering framework. And for me, it will be the main difficulty in the industry from what I've seen.
And what emerging trends do you see in the field of interpretable AI for portfolio management?
the main field and the one that I would like to see it growing. So the main field is sharp value, which is something coming from game theory that explain the forecast after the fact. It's quite complex to estimate. It's quite complex to understand, and it doesn't work so well. In fact, it can be tricky. There are many papers that say that you can change the features and you get different interpretation. So you basically don't understand that. I do not like this approach at all. And what I would like to see is more interpretable models by themselves. Really, like the one I'm using, but it's a 2008 paper. I'm sure that we can improve on this methodology and on this kind of approaches.
Thomas Raffinot, thank you very much for joining me.
Thank you very much for your time.